Hello, and welcome to Mission to Mars Binary Counter. In this presentation, we will take a look at the binary counter that's presented at the end of the movie Mission to Mars and learn how to make that without keyframes in Cinema 4D, After Effects, Maya, and Houdini. Here's the end sequence of Mission to Mars, and let's take a look at the binary counter.
Rover, this is ERB. Do you copy?
Phil?
Oh, thank God, guys.
Phil, we read you.
That's right, I have 4 files here, the project files. We will learn how to create the counter in these 3 applications, Cinema 4D, Maya, and Houdini, using Python, and Extend Script in After Effects. Here's what it looks like in Cinema 4D. After Effects. Maya. And Houdini. Okay, let's get started. Before we begin, remember, may the horse be with you. Here I am first in Cinema 4D. Now, a binary counter is a way of counting where each step follows a power of 2. For example, 1, 2, 4, 8, 16, 32, 64. Now, in normal counting, every number increases by 1, but in a binary counter, each digit flips at different times. For example, the first digit flips 1, and then again, and then again, and then again. So the pattern is 1, 0, 1, 0, 1, 0. The array always starts with 0. So 0, 1, 2, 3, 4, 5, 6, and there are 7 elements. 2 to the power of 0 is going to be 1. 2 to the power of 1 is going to be 2. 2 to the power of 2 is going to be 4. This will be flipping once every second. This will be flipping once every 2 seconds. This will be flipping once every 4 seconds, every 8 seconds, every 16 seconds, 32, and 64, and so forth. Okay, so let's move on and start from scratch. I'm going to create a new scene here in Cinema. I'm going to create the torus by going to create mesh torus 364, and let's just do 18. Now I'm going to go to camera, show camera attributes, coordinates, and I'm just going to change this to 90, negative 90, 0, and 0. I'm going to zoom out. Now I'm going to add a cloner by clicking this button here, just add cloner object, or I can go to MoGraph cloner, and I'm going to drop the torus inside the cloner, select the cloner, go to object, mode, linear, and I'm going to change the count to be 7. We can change this later on. On the Y, I'm going to make it 0. In the Z, I'm going to make it 800 is good. And now we have these objects in the cloner. Now for effectors, the effector that we want is going to be the Python effector. To access the Python effector, we can click here and we can go to Python, or we can go to MoGraph effector and just click on the Python. Now we have a Python effector in our cloner, and we can turn it on or off and on or off. And to access it, you can click up here or just double click in the effector. Now in the effector, you notice if we turn it on and off, we see a jump in the y-axis of these objects. That's because in the Python effector, under the effector, you see we have 2 options here. We have parameter control and we have full control. If we have parameter control selected, we can click on parameter, and we see here that the parameter is affected. We can choose to affect position, rotation, scale, or any of the other parameters here under parameter, such as the transform, the color, or other. And in fact, if we scroll down here, you see it returns a vector object. That's because it's computing the output here and it's returning it as a vector. But we're not going to use parameter control, and in fact, let's go to full control. We want to manipulate any parameter and just output that to the cloner. So I'm going to select everything under full control and hit delete, and we can start from scratch. So here I'm going to select Open Python Editor. Now when doing Python in expression editors, it's very handy to go to Extension Console, where here we can get sort of like a debugging, and we can see if we have any errors. For example, I can clear the screen. If I just type something and execute, we see here, yeah, we get an error. Okay, let's start programming. Now, the first thing, we want to import C4D and math, because we're only going to be using some math functions such as cosine, pi, radians, and so forth. Now, we want to incorporate some user data, so we'll add some parameters to the Python object here. And to do that, if we select Python, and here under the attributes, if we select user data, we can add some user data. And we're going to add 3 parameter controls. The first one, animation length, and that's going to be a real number, but we'll limit the min to 0. And you see here the ID is set to new. So it's going to get a new ID. If I hit OK, and I come back here to add user data, if we select animation length, you see here it has an ID of 1. This is very important. Okay, let's add our second user data, rotation interval. This is going to be a real number, but we're going to limit this to 1. And for the steps, we'll do 1,000th, add another user data. And for that data, this is going to be a Boolean, and I'll just call it easing. The data type is going to be Boolean. And if I hit OK, and I come back here to manage user data, you can see that has an ID of 1, an ID of 2, and an ID of 3. Now this is going to be very important because in Python, we can reference this user data by referencing the ID number. So let's add a comment for our parameter controls, and the first parameter we're going to do is the animation length. So what OP is, in Cinema 4D Python, OP is a reserved variable that refers to the current object. And the current object we're on is Python. For example, if I just print OP, you can see here we get the Python object. Now C4D.userData, that's going to be a special flag, and it accesses the user data parameters from the current object. So this is going to access all of our user data that we have stored here under user data, and we can see our values here. So remember 1, 2, and 3. So if we want to retrieve the float value for the user data inside animation length, we can just have the number 1. Same with rotation interval and easing, just defining the variables here, and we can have 1, 2, and 3, and that's the ID numbers for this. So now we can print our animation length, our rotation interval, and our easing. If I hit play, you can see here we get our values here. And if I change that to on and change this to a different number, you can see we get those numbers right there. Perfect. Let's continue. Now I'm going to define an easing function, just a very simple easing function. That's going to take in time float value, and it's going to return a float value. And it's just going to be a simple sign-based easing function for smooth interpolation between the frames that we're going to be referencing. So there's the code comment, and this is the function right here. That's the math, but because I have my easing enabled checkbox, I want to add this line to say to return this if easing is enabled, and if not, to just return the regular time value. So we have our first function. Now you see this error here, it says could not find main in effector Python. What this error means is in every Python effector, you need a main function. So I'm going to define main, and in this main function, it's always going to need to return a Boolean. The reason it's going to need to return a Boolean is if we go to our effector, we're in full control mode. Now, if we were in parameter control mode, we would need to return a parameter, maybe a vector or a Boolean or something. But full control mode is always going to be setting the data here in the main function and returning true or false. Now we don't see any errors if we hit execute. This is a good sign. Okay, I'm just going to add a comment here in our function. This is going to be the binary rotation effect for the MoGraph cloner in Cinema 4D. To access the MoGraph, this code, c4d.modules.mograph. That's the MoGraph module in Cinema 4D. Now to retrieve the Mo data, that's the MoGraph data, for the current Python effector in this object, we can use a function called gegetMoData. So gegetMoData, and we want to get that for the current object. And we can just set that to a variable md for Mo data. Now again, this line right here retrieves the Mo data for the current object, OP. We can grab this for any object, but we want the data for the current cloner. And now here's where we can add a little if statement that says, well, if this is none, we can just return false. Okay, now a couple variables we want to set. Now we want to get the clone count and the transformation matrix for the current MoGraph cloner. So let's get the count and the matrix. For count, that's just MD. We're going to reference that. We're going to get the count. And if we print count, we should get 7 right here. And we do, because that's how many objects we currently have. Again, the matrix. We want to get the matrices for the Mo data. Now, if we print matrices, you see here we get the values here of all the matrices. We get 7 of them. And we can print individual ones by doing just accessing the first object in the array. And here we get the first one. That's the first cloner. Now we need to get the current frame and time. So let's add a note and let's get the frame number. We're going to get the current document and we're going to get the time. And if we print that, you see here we get a base time object. But we don't want an object, we want a number. We want a frame number. So let's call the method getFrame, plug in doc.getFPS, and now we should get a frame number. If we move to frame 24, we see here updates to 24. We move to 36, we see 36. Or if we hit play, you see we get all the frame numbers. Now moving on, now to get the time, we're going to do frame divided by animation length. In the user data, with the animation length, I'm going to change to 12. The rotation interval, I'm going to change to 0.5, and I'm going to add easing. Now, if we print time now, you see now we're getting decimal points. And this is exactly what we want. Because you see I stopped here on 12, time is 1. So time isn't really a matter of seconds, but it's saying that 1 is every 12 frames. And this is very important for when we do our math. To get started with our math, let's loop through each of the cloner objects and apply some math to that. So let's do for I in range count. And here is our binary math. We're going to do 2 to the power of each of these objects. So to do that, let's do interval, and that's going to be 2. And in Python, we can do 2 star. That means to the power of I. And let's not forget to add an equal. Now, if we just print that interval, we should see the binary calculation. And we do. We get 1, 2, 4, 8, 16, 32, and 64. Good. For steps, we're going to do math.floor, and we're going to do time divided by interval. Now, if I execute that, you see we get 1 followed by a bunch of zeros because I'm on frame 12. If I'm on frame 0, you see we get all zeros. But now if I go to frame 36, you see we get 3 and then 1 and then 0, 0, 0. What that means is that the first object had already gone through 3 steps, while the second one had only gone through 1 step, and the rest are at 0. If you know binary, it makes sense, but it's also simple math. We just calculate the time divided by the interval. Now this next line is very important because for each of the matrices, we want to add 90 times the current step. This isn't the animation, this is a rest position based on how many steps each object had gone through. So with matrix math, we're going to multiply this by the current matrix. So we do multiply equal, and we are only going to be concerned with the rotation x value. So c4d.utils.matrix.rot_x. But before we continue, let's go into the Python object. Here we need to add a field. What this field is going to do is if I add a solid field, this is just going to allow the effector to affect everything. So in this for loop, we're going to set the matrices that we got from up here, but we have to reapply the matrices. And in order to do that, we call md.setArray, and we're going to set the Mo data matrix. The same thing from we got here. We got the array. Now we're going to set the array, and we're going to set it with the same matrices. Oh, now we saw a change, and that's because we have this value 90 here. If we added 180, we execute it, now we get some more math. But we want to convert this to radians. So we just do math.radians, and now we get the proper value. So if I do 90, you see now they're all rotated 90 degrees. 45. Now they're all rotated 45. But what I want is the steps. Now, since interval is called here, in steps defines how many steps the binary counter has passed through. So if we do 90 times steps and hit execute, and we scroll our timeline, you can see now that there is some sort of animation happening. Actually, the animation is happening in the wrong direction. Well, it looks like I might want to rotate it on the Z-axis, which is fine. And there we have it. If I change the timeline to maybe 3000, see, I can continue until it loops all over again, which is kind of cool. We have a timer. If I click on my Python object and go to user data, now if I change this to 24, you'll see it happens more quickly, but I do want 12, and we'll see why here in a second. Now we want a phase. This phase variable, time, ampersand, or modulo, interval, what that means, the modulus operator calculates the remainder when dividing time by interval. So time keeps increasing every second. This interval is the delay between the binary step. But this phase, it resets the cycle every interval seconds. And this is important because if our phase is 1, that means time is 1 frame into the new cycle. And so, well, why that works for binary counters is each cloner follows a binary progression. The first clone resets every 12 frames like we have here, animation length. The second clone resets every 24 frames. The third every 48 frames, and so forth. Now, this is important because the first half of the interval, or rather this rotation interval, means it's rotating. So if I turn this to 0, that means there is no animation interval. It'll just skip. But if I turn this to 1, that means it's constantly rotating. We'll see how that works in a second when we write the code that's going to define our animation. So in order to have that work, we're going to say if the reset is within the rotation interval, it's going to do the math. And I'm just going to paste the math here. It's basically the same here. We're just getting the matrix and multiplying it by this value, rotation Z, math.radians. But here's the math right here. 90 degrees times, we're going to do this ease in and out function, phase divided by rotation interval. Now this is very important. And then we're going to add 90 to that. And well, that's it. If we hit play, now we do. We have the animation. Now we have that animation because we have this code here, but also these variables here. Now if I hit stop and I turned off easing, it doesn't ease. But also if I turn this rotation interval to 0, you'll see there's no animation because there's no interval. It just immediately skips over this line of code because phase is never less than the rotation interval because the rotation interval is always 0. But look what happens if I change this to 1. If I change it to 1, now this is always rotating. There's no interval. And I can change this to 24 frames. And what that's going to do is it's just going to rotate a little slower. But in this Mission to Mars video, it's quick. And so to match that, I'm going to turn this to 12, going to turn this to 0.5, and I'm going to turn on easing, close this, center that. To make it exact, I'm going to click on torus, maybe just do positive X orientation, and there we go. Now it's exactly it. And if we wanted to animate the cloner objects, we can animate them, and we could make it as long as we want, and we'll always animate as many objects as we want. But of course, that timer would be very, very long to reach the end. And so the one that matches in the video is having 7 clones, and here we are. So to summarize, in Cinema 4D, we have a cloner, we have an object. I selected plus X. Inside the cloner, I made it linear, have the count of 7 per steps, 800 centimeters. In Python, just make sure you have a field of solid. User data, I added the user data info here from this menu here, user data. And in the effector, I selected full control. And here in my Python editor is the code. Now we're going to reuse this same logic, the same code, mainly this math right here. We're going to use this in After Effects, Maya, and Houdini. Okay, let's move over to After Effects. All right, here I am in After Effects, and we have this animation sequence right here. Well, let's get started. I'll create a new comp, and what I did is I just made a camera and the background. That's fine. For the object, I went to Layer, New, Shape Layer. And in Contents, I just added a ellipse, made that 500, duplicated that ellipse, maybe made it 450, one to the position value and the other to the rotation value. Let's make it a 3D object. So add an expression to the position and to the X rotation. In the position, I added this expression here, which basically says I want to offset it in the X direction for 550 multiplied by the index minus 1. And what that allows us to do is if I apply that expression and I hit duplicate, it'll just duplicate and move the object across. But what we're interested in is the X rotation value. Now I'm going to paste the code and just review it. You'll notice the same as we had in Cinema 4D. We have a function, ease and out function. Here we set our variables, animation length, rotation interval, and easing enabled. I set that to true. And here we have the in and out sign easing. For frame, I used the time to frames. To ensure animation length is never 0, to avoid the division errors, we do math.max, animation length, and 1. We want to normalize the time, so frame divided by animation length. We do want to get the current layer index because, well, we're not running a for loop, but we do have to get the layer index number. So here's how we do that. That's math.max. Index minus 1, and it ensures that the index starts at 0. That's why I moved the camera and the background to the last of the layers. Now the base rotation, again, just like we had in Cinema 4D, steps times 90. For the phase, time norm modulo interval, that's the remainder, and here's the math. Instead of multiply equals, because we're not doing matrix math, we just do plus equals. So we set the rotation angle here initially, and we want to add the animation, that's 90 times our easing function, phase divided by rotation interval, plus 90, and of course we return the computated rotation. Now if I just hit play, you'll see it does that, on, off, like binary. But if I added another one, you'll see it does that. And if I add some more, you'll see we have our binary counter. No keyframes, which is pretty neat. And of course, we can link these expressions up to a null object if we want to define these values here. To do that, we can add new null object, and I'll just call this object like I can call this object Super Daddy, and for the Super Daddy, I'll move that down at the bottom, and we can add some controls here, maybe a couple slider controls and a checkbox control, right? I can call this one animation length, and this one I can call rotation interval, and this one I can call easing enabled. We'll enable it, turn that to 12, 0.5, and we can just link these up. Now if we hit play, we can adjust these, and you see it's much slower now. But we won't see it affect until let's add some more. And if I change this to 1, yeah, you'll see it's always spinning. 12, make it spin faster. 0, we'll just get steps. Yeah, cool, yeah, After Effects, but let's go into Maya and Houdini. Okay, here I am in Maya, and this is the animation here, and it's full. I wanted to show you what it looked like in keyframes. Okay, let's show this group here to show you what it looks like with keyframes. Well, if I highlighted all these, you'll see that here is the binary pattern. And in order to accomplish that, I selected all the keyframes and went to curves. For pre-infinity and post-infinity, I selected cycle with offset. What that does is it's going to cycle the animation, but with an offset. And that's why you can see this step ladder increase. And well, of course, you don't want to do that. We want to do it procedurally. So let's do that. So here I created a torus. I went to create polygon torus and just added in some values. 90 degrees. I think this radius maybe 1.4 and section radius maybe 0.1 and increase the subdivisions. So here we have our shape. Now what I used is Mesh. Mesh is kind of like just an animation tool for Maya that allows for really creative things, including Python. So I'm going to select my object, and here, Mesh, I'm going to go to create Mesh network. network. Or I believe it's under the animation menu, mesh, yes, create mesh network. I'm gonna select my object, create mesh net. Now what that does, it hides the mesh, but now my repro mesh is basically the reproduction of whatever's happening in my mesh network. Now I have my other mesh networks from before my experiments, but let's focus on this one here. So we have a distribution node, and this distribution node, what that does is distributes my objects based on the number of points. So if I did 7, if we wanted to increase or decrease the distance between them, we can play around with this slider here, but I'll just leave it at the default, which is 20. Now, what we're interested in is if we select mesh, we can see, or we select the node here in the outliner, we see here we have a Python node. So I want to left click and go to add Python node. And what that does is that adds a Python node right above the distribute node. We could turn that on and off if we wanted to. In the Python node, it's kind of similar to Cinema 4D. And you can see this is what it comes with as standard. It shows you a way to update the instance's position. Well, let's use the same logic as we did in Cinema 4D, but let's use this in Python here. It's going to be a little different, but the logic is pretty much the same. So what we want to do is we want to create some custom attributes, and we can do that by going to, we can select, make sure you select the Python node. It just makes more sense to add everything in the Python node, but we can add attributes just like we did in Cinema 4D. The first one, animation length, that's going to be a float, no minimum or maximum. Add it. When we add it, it appears here on the bottom of our Python node. I'm going to set that to 12. I'm going to add another attribute, and this will be called rotation interval. It's going to be a float. It's going to be a minimum of 0 and a maximum of 1, just like the other. Add, and I'm going to set this to 0.5. I'm going to add a Boolean called easing. And here we get our checkbox, and I'm going to have that checked. Now, the first thing when dealing with mesh in Python is we want to import open mesh, and we're going to be using mvector, which is part of Maya's API. So let's import that. We're going to be using the mvector as vec. You know, in order to get our cosine and pi, we want to import math. Actually, let's organize that a little better. Okay, here we go. We want to get our attributes here. And so in order to do that, we can just call them the same. We're going to call cmds.getAdder, and this is just Maya standard Python code. And this here, animation length, we can get that value from our script editor. If we change the value, let's say to 24, we can see here it's capitalized animation length. The reason it's lowercase, and it should be lowercase, is when creating attributes, you can just create it like animation length and add that, and it will correct it, as you can see here with capitals. Let's just change that to easing. Yep, animation length, and let's add rotation interval, float 0 to 1, add, and let's change this back to lowercase. Okay, we're good. Now, if you want to check that it's working, just go to the start and hit play, and you see we don't get any errors. And if we want to print and make sure that we're getting the value, let's print, and yes, we should get 24. And with our rotation interval, let's do 0.5 and make sure we're getting that correct value. Yes, 0.5. Okay, good. Now we don't need a main function like we needed in Cinema 4D, but we can add in our same easing function. And this is just a direct copy. That's the same easing function as we had in Cinema 4D because this was Python. But we do want to initialize the mesh data here at the bottom. And we can do that by calling open mesh data this node. Now this node gets all of our clones here. And of course, we want to set the data. But in between here, let's create a function called update rotations, and we'll pass in the data. I'm going to call this update, maybe just update values. Now, of course, we're going to get an error here at the bottom that says update values is not defined, but we can define that right here, update values. And let's just print the data just to make sure that our function is working. And it is, yes, because we get the mesh data. Now let's pretty much duplicate the exact same thing that we did in Cinema 4D. And in order to get the frame, we just call the data.getFrame. That's whatever frame that we're on. We want the time. We want the time in seconds. So frame divided by animation length. And if you remember, we can call our for loop. And let's print I just to make sure we're getting our loop. And yes, we are. We're getting 0 through 6. Now, just like we did in Cinema 4D, we want to get the interval and the steps. So we want to calculate the rotation steps for the binary progression. Here is the rest rotation, right? Just like we had in Cinema. And let's add our easing function. Same thing, get the phase, time, modulo interval, and have it say phase, rotation interval. And we calculate the rotations 90 times, again, our ease in and out function up here. Now what's important is we have to get the rotations. And here we want to put the data inside of this rotations array. And we do that by right here. Now, this isn't being set to anything yet, but we do want to set the data. This is very important when dealing with MASH and Python. To set the rotation, we do data.outRotation, and we can do that by creating the vectors. So let's set that. Let's do vec. That's from our M vector here at the top. And we do the rotation 0, 0. And our rotation value is going to be for rot in rotations. Now, as soon as we did that, you see it just starts animating. So we did it. This is the function and the math and how to use Python in MASH to create an animation without keyframes. Now we can turn this animation length to 12 and that'll immediately start moving a lot quicker, which is just like how we have in Mission to Mars. Very good. Okay, so here we have it in Maya. And now for Houdini. So here is the animation in Houdini. It's lagging a little bit for some reason. But let's create a geo node, jump inside, let's create a torus, and let's drop down a line. Okay, let's change some parameters, 0.5, 0.05. Let's rotate this maybe 90 degrees. We'll have it start there. And yeah, that's fine. For our line, let's do length. Well, let's do the direction here. Let's do direction 1 on the X. 0 on the Y. Show points for our line. We want 1, 2, 3, 4, 5, 6, 7. All right, we want 7 points. All right, and the length we'll do 6. Now, if you haven't guessed already, we'll be using copy to points. Right, and there we go, and there we go. Yes? Oh, that looks a little too big, so let's adjust this to 0.8. Now for copy to points, we can just pack an instance. That'll just put a single point there. But now our code is going to be written in Vex, and we can use the attribute wrangle. And we'll do that right after the line. Because what we're going to be doing is we're going to be rotating and adjusting the orient of each of these points. And so the last line of our code is going to be this right here. We're going to create p.orient, quaternion, radians, and rotation. So if I do float rotation equals 90, I'll rotate 90 degrees. And we need this radians and the quaternion. We need to pass through that. We want it to affect on the x-axis. If we wanted y2, we can put 1 there, and you'll see it affects it on the y. And the z, of course, is right there. 0, 0. So we define our rotation. I'm going to make this green just to show that there's going to be animation here. But just like the math that we had in Python, we want to get the current frame. Now, because in Houdini, the frame starts at 1, I'm going to add frame -1. because I want it to start at 0. And I is going to represent pt num, which is going to get the current point index. Now, if I go to my geometry spreadsheet, you see we now have our orient values right here because we created an orient attribute right here. Now, p.orient is specific so we can reference our points when passing through to copy to points. Okay, let's create our parameters next. We want a CHI, which stands for an int, CHF, which means a float, and here I just named them. And if we hit this button right here, you see we get our sliders. I can set that to 12. I can set that to 0.5. Here's the same easing function and a CHI easing. And what I'm going to do is I'm going to go here to edit parameter interface, and I'm going to add a toggle right here. And I'm just going to call this easing, hit accept. Now we have an easing checkbox. And we can access that easing checkbox by using a CHI, an int, which basically 0 for off and 1 for on. Basically the same thing as we had in our Python. Now for the time calculation, we can just have a normalized time value, which is going to be frame divided by our animation length up here. And we can get the binary progression and the rotation interval, the power function, so 2 to the power of I. We can compute our rotation steps by doing time divided by interval. And again, we want that to be an int and a floor. And we calculate the rotation angle. This is basically the initial rotating angle. And we do that by doing 90 times the steps. And this might look familiar. To calculate the phase in the cycle, and actually we defined rotation, so I can delete rotation 90, but we can do rotation plus equal 90. And here's our ease function. And we pass the new rotation into our orient, turn it into radians, into a quaternion, and voila! We now have it animating perfectly. And we can adjust this. Again, if we do 0, there's no animation in between. Go all the way to 1. You see now it's constantly spinning. Turn off easing, and we just get a spinning. Or we can do 0.5. We can turn this to 24. But to match, let's do 12, and here we have it. A perfect match. Well, I know this is a little technical, but after watching Mission to Mars again, I really wanted to create this in all of my 3D applications, using no code, Python, and scripting, and I hope this proved useful in some way. I feel like it's a great introductory to Python effectors, to Mesh and using the Python node, as well as maybe using a little bit of Vex. Of course, it's very helpful if you already know these 3D applications, but if you have any comments or questions, please feel free to reach out, and I'll do my best to try to answer. Thank you for your support, and live long and prosper.